I hope you are able to hear me clearly. Thanks to Ipta, once again, I'm back here. I've done some sessions earlier. This will be a very interesting one, considering the state in which the present industry is operating now in the economy as of now. So this will be a very good one to not only for the chemical recovery but for the whole mill. So advanced process control is nothing new for some of you. Maybe some people may be needing this. This is almost used in globally many other mills. So basically we have a hierarchy as you see here. You have equipment, sensor, you have the DCS, then APC, then the artificial intelligence or machine learning. So that's how the hierarchy goes. And then the controls, they go synonymously, as you see there. So the key benefits, as you see here, better fuel and chemical management, that is what is needed. Improved quality of the final product, then less process variation, less environmental chemical load, then you have to use the assets very well. These are all the basic things that are needed. So then how it is done? APC uses the mathematical algorithms. The previous speakers have already taken you through that. Then optimize the production yield while minimizing the energy consumption. APC is needed is an added value upgrade to your process automation. Basically, you have to improve the process that you are doing. The information gathered is then used to stabilize the process. So that is how you adjust the set point closer to the limit. I'm going through this session for people who want to know more nitty-gritties of what is this advanced process control and what it is. So then I will take you through the chemical recovery and then end up how it has to be done. So you have a single loop APC and a multi-loop APC. You have the advanced regulatory control, multi-loop control. It is called feed forward, then adaptive gain, closed single loops, and on the other hand the multi-loop is the complex, firstly the model predictive control, and then the complex pros and cons well known. Close multivariable loops automate multivariable control. So basically it consists of model predictive control. Then you have the soft sensor, then the feed forward control, which are all used in the process in different ways to optimize. So how that is used in the evaporator is, what is needed in the evaporator optimization is the energy efficiency, how the steam is used effectively to have the evaporation of the total capacity. Then stabilize the dry solid. If the dry solid is stabilized, then recovery boiler is sustained very well. So that is the ultimate. I have taken very, very important points to stress how we have to focus on. Then the production rate control. If these three things are done, then the chemical recovery is automatically taken care. That is from evaporator point of view. Then it goes to the recovery boiler. So with this APC, you can have this cost optimizer, then performance monitoring, and key performance indicator you will have on the dashboard. performance monitoring with both on-site and remote. So that is what the previous speakers have taken through. That is on-site, and then the autonomous, which is for the remote, maybe the owner who wants to see how the plant is running. So today he can do wherever he is. So that is how it is. Then task-oriented and user-friendly, that is most important. So in an evaporator, the model predictive control is how you change the feed flow or the steam pressure across the evaporator vents. And then the key point is the boiling point. Every liquor behaves differently. How you predict the liquor for the boiling point rise is the key to evaporator control. And fouling and scaling management, almost all the mills who are here are facing the scaling. Can anyone say here, I don't have any scaling problem at all? Any one of you here, we can have a discussion. Then the feed-forward control, it anticipates the disturbance because today's situation is raw material is what you get. That is what you have to process. This is the management requirement. How you adapt the recovery process for that raw material. I think this is the cardinal point of the whole mill operation. So next we come to the recovery boiler. Most important is the combustion air. If you can do the combustion air very well, most aspects are taken care. That means you are optimizing on the efficiency, on the steam production. Then when you have certain other controls which follow in the presentation, you are automatically taking care of rest of the aspects in a recovery boiler. So combustion control I have put as the most important aspect. There are a lot of slides relating to that. You can see here, every 1% decrease in boiler excess oxygen yields a 0.5 to 1% increase in efficiency. These people have to think deep to understand and then try to implement this. This one slide gives you the totality of the recovery boiler control. I hope some of you will be doing it already. You have the combustion control, the liquor control with reference to the feed as well as the temperature and then how the spraying pattern is, etc. Then how you optimize the whole thing. The very aspect of this control requirement, that is advanced process control, is every day, every hour, liquor behaves differently. On no day, the liquor is taken for granted. So it is very difficult from human point of view to make the adjustment. So all those database, which is called big data, some of the speakers have already talked. So it is analyzed, and then the model predictive control, which is part of the APC, takes care of that variables. So to have a reasonably organized way of operation, which is to enhance the efficiency from a steam generation point of view, and then how you optimize the liquor from the reduction efficiency point of view. So these, which is top and bottom, two things are there only in recovery boiler. One is the bottom reduction efficiency, and the top one is the steam generation. If you are able to have a combustion control, steam generation is better. If you are able to have a good combustion from the primary air point of view, then reduction efficiency is taken care of better. So this is very important. We can have a detailed session because the time is limited. Soot blowing is one of key aspects because People may say, why you put soup blowing as separate? Because boiler generates HP steam and you are using the HP steam. I want to utilize it in a very, very organized, optimized way. So that is called smart soup blowing. How I will operate the soup blowing, in what areas, what speed, what steam consumption, given the fouling characteristic of the recovery boiler ash which is generated, decides how you spend the steam that is. In another way, in a difficult way, it is generated. So you have to optimize the steam which is used in the recovery boiler. So that is why that is put as a separate one. Then the reduction efficiency, as I was talking, very, very key aspect in the chemical recovery boiler. We can talk more in deep, people who want this, because this has got, in many mills what I have seen, reduction efficiency is not controlled or is not measured correctly. So very, very important. Then we have same continuing on the reduction efficiency, the importance of how the chemicals are saved as part of this. So then coming to costicizing, only two key aspects I have taken. How the total titratable alkali that is required for the white liquor, which is decided based on your pulping process. So it is set from the green liquor. You have an analyzer. Some of the mills cannot in India employ that because it's a costly one. But people who can do, this will be a very good thing. So from there, the green liquor starts in the PTA control. Then it goes to slaker. Slaker control is the most important in the plasticizing process. You have the temperature difference between the slaker and the classifier. You control based on the ratio of green liquor that is fed and then the lime that is fed. So this control can be easily done. You don't need a very smart brain or a very, very advanced process, etc. So basic things are needed. Why I am stressing, I will come to the end of this. This is how the total control is. Unless we do the basic process very well, advanced process has no meaning. So this is very, very important for people to understand. First, we have to set what is the basic process and then how it is done. Then you graduate from there. So then this is the cost sizing efficiency, which is based on the Goodwin's curve. Many of you will be knowing about it, based on the salinity of the liquor. So this is how the control takes place. You have the PTA benchmarking and the cost sizing efficiency benchmarking. Coming to the lime kiln, you have to produce a high quality lime based on what is the garbage you put in. This is what you can do. So in a lime kiln, how you are utilizing the calcium carbonate that is coming and then converting effectively decides how the lime kiln is done, and of course how the burnt lime is then fed to the slaker and then cost side. The loop within the loop, as they call it. So here you have the cold and temperature control, oxygen control, CO control automatically, then the production target. So this is how the controls are done based on the fuel flow and fan speed. Lime kiln has to be economical for the mill to sustain. sustained. So the line in operation has to be optimized with the fuel. Today the fuel is quite costly as well. So we have to optimize the whole fuel input for the burnt lime conversion. So that is how the optimization comes here. The next slide, of course, talks about the stream network optimization, which is obviously an important one, because how you utilize the steam in the stream network is also important. So this is how the model predictive control works. I have just used the terms for people who get a better understanding. Otherwise, people who are operating may not know what are the ingredients into the process. This slide, please focus on this. This epitomizes the whole advanced process. If people want to have a good understanding of this, you start with conventional operating environment, and then obviously everywhere in the world you have the constraint. How you optimize within the boundary is how you get. So this is all about what is advanced process control or digital twins or whatever you say. That is what you are looking for, most profitable operating point. So next is the AI-driven thing that is part of that. Then the results and discussion, I will take just 1 minute, couple of slides only. So evaporator train optimization is from the stability and energy efficiency. Recovery boiler is from furnace, bed and furnace management and the steam generation as we talked. Costicizing is about the white liquor quality and lime in fuel saving. Overall, gives the opportunity for critical control and then without operator intervention. That is the most important. So the return on investment, depending on what is the base level of the mill operation, would be 12 to 24 months. Most important in the conclusion is how to sustain the APC, which is otherwise there. So you have to involve the operator and the management directive should be there. You have to performance stability and underlying conventional control for APC. Very, very important point. Training and then secure long-term support of the APC components, whoever supplied. So these are certain cardinal points. Thank you all for listening.